A very good morning. I'm Professor Kalyan and we are here to discuss about ultrasonic sensor and its principle of operation. Just to start with the introduction of ultrasonic transducer, I would want to tell you about the figure which is displayed on the slide. A plane wave with intensity II hits the surface of an obstacle and it reflects partially some amount of energy, and it also transmits some amount of energy with powers IT, with the intensity IT and reflected intensity IR respectively. The impedance offered by the transmission media is Z1 and the reflection media the transmission media is Z2 and the reflection media is Z1. An ultrasound is mechanical vibration which is created in a media, and basically it has a frequency greater than 20 kilohertz. As for any radiation, it also has got the nature of reflection. It obeys also the absorption. It obeys also the transmission. And in addition to this, it obeys the Doppler effect also, wherein when the source of ultrasonic generation and the reflection surface both move, there will be a frequency shift, about which we will be talking more about in the next few slides. My second slide will take you to the basic arrangement of ultrasonic transducer measurement used for distance measurement. This will basically give you an idea of how would ultrasonic transducer operate. A control circuit is a timing circuitry which will say when to transmit an ultrasonic pulse and when to receive a pulse. The transmitter here basically is a piezoelectric transducer which, when given an electrical impulse by control circuit, generates a mechanical vibration in the media. These vibrations hit the object, and these vibrations essentially would have a frequency greater than 20 kilohertz and hit an object which is placed at a distance of L0. It reflects back some amount of power which is received by the receiver here in the circuit, which is also a piezoelectric transducer, which will convert the mechanical vibration into electrical impulse and then give it back to control circuit. The time taken between the transmission and the reception can be one type of measurement, which is called frequency Doppler measurement. Other way of measuring the distance here, the L0, is calculating the intensity, wherein the distance traveled by the higher is the distance traveled by the ultrasonic pulse, lower would be the intensity received on the receiver circuit. So if the intensity is lesser here on the receiver, that is evidently saying that the transmitter has traveled a longer distance. That says that the object is also placed at a larger distance. So the distance is inversely proportional to the amount of current received here on the receiver, is with respect to intensity based measurement. And if the frequency, that is that you have applied a pulse here, and the pulse is applied at a time t1, and the pulse is received back again with a lesser intensity after time t2. The difference between time t1 and t2 is giving you the direct measurement of the distance traveled by the pulse. Larger is the distance traveled by the pulse, the greater will be the reception time, which is similar to something which happens in the echoing effect. You shout, it hits. If the cliff is far away from you, the distance traveled by the distance traveled by the pulse is d. It takes 2 times the d and 2 times the t, that is 2 times the time traveled, is the time of flight, is the total time taken. And larger is the cliff distance, larger would be the time taken for the pulse to return back. So this is called the transit time concept. So we can measure the distance in terms of intensity and also in terms of the time of flight. Now let me introduce you to some fundamentals of ultrasonic sensing. There are some terminologies which we all have to be acquainted with, like a term called frequency, amplitude, and instantaneous velocity, and the average net velocity of atoms. See, the instantaneous velocity is the velocity which changes with respect to the distance and with respect to the time. The frequency is the sharpness of the wave. That is, the frequency here talks about the I have another way of explaining this to you. Let me now first explain you the amplitude part. Amplitude here talks about the intensity of the wave with which it reflects back or with which it travels in the media. The wave velocity is defined as the velocity for the perturbation is the disturbance in the media to propagate from one point to another. It depends upon the viscosity of the media, It depends upon the resistance offered by the media. Resistance here refers to the Z1 and Z2, the impedance offered in the media. Here C square is the velocity, C is dependent also on the temperature. When the temperature is high, the viscosity of the gases or the media also decreases, as a result of which the total impedance also reduces. So the velocity increases, which is given by Km by rho. Km is the bulk modulus velocity, and Km is the bulk modulus of elasticity, and rho is the specific resistance or the resistance offered by the media. And the velocity here varies for solids, it varies in two different ways: longitudinal waves and transverse waves. We all know about longitudinal waves. They transmit parallelly to the source, and the other one travels perpendicular to the medium. One is longitudinal waves, one is transverse. These are the formulae given for the velocity, which is just for your information. What is important for us now here in the sense in the presentation is the sensing parameter. See, one would be the acoustic pressure, which can be measured, which is the wave velocity. Another one would be the acoustic impedance, which will again reduce the intensity of the media. The pressure given at a point, say for example, the wave is the source is generating a wave, an ultrasonic wave. The pressure, acoustic pressure, that is the vibration, the pressure which is generated because of the vibration in the media would be quite a very high one at the source, while the vibration, the pressure, it reduces as and ever it propagates in the media. So this pressure, if the pressure is inversely proportional. Say for example, the larger the distance traveled by the vibration, the lower would be the pressure at the point. So if you are able to measure the pressure at the remote location, that is the direct indication of the distance traveled by the acoustic wave or ultrasonic wave. And the impedance, higher is the impedance or the viscosity in the medium, or the distance traveled also reduces the intensity. The media can be generally classified as two: homogeneous media and inhomogeneous media. Here, the media, a homogeneous media is the reflection and the transmission. Both of them are in the same media, wherein the Z1, the impedance offered by the media, is same. In this case, the intensity, look at this relation, I naught into e to the power of minus alpha x. Minus alpha is the coefficient, is the attenuation coefficient of the media, and I naught is the incident intensity of the wave. So intensity, the initial intensity decreases as a function of distance x in a homogeneous media. But in an inhomogeneous media, wherein the impedance offered is not same, that is, you have a Z1 and you have a Z2, you have a Z1 and Z2, and the object is here. This happens mostly in the case of transmission. A wave hits and transmits, so it encounters two media, Z1 and Z2, and the total impedance offered by Z1 and Z2 would be given as a relation here in the mathematical equation here: Z1 minus Z2 by Z1 plus Z2 Z whole square. So the total ratio of transmitted and incident intensities is given by the total impedance, as this relation says. So this impedance should be lower for a higher intensity, and the impedance should be larger for the lower intensity. The total incident energy, reflected energy plus the transmitted energy should always give you 1. The normal incidence of the power density should always be equal to 1, either it be in gaseous or it be in solids. Ultrasonic based methods basically are the ultrasonic sensor transducer can be used as sensor by the function of transit time, attenuation and velocity. Only 3 functions. The material used, generally the piezoelectric transducer, which I've already discussed about. The resolution here is limited to the wavelength, which is inversely proportional to the frequency. We all know that C is equal to nu lambda, and higher is the frequency, lower would be the wavelength, is the basic fundamental fact here. The sensitivity and range depend upon the relative position of the object and also the reflector. With respect to this example talks about an ultrasonic transducer being used for level measurement. You have a transmitter and receiver here, and the time taken for the traveling, if assumed as t, the t and the reflected time is also t here. The total transit time is called as 2t here, is calculated as 2t. If the level of the tank increases, the time taken for one transmission and one reception also decreases. So larger is the level, lesser would be the transit time. Lower is the level, greater would be the transit time. So the transit time here is directly affecting is getting affected by the level of the water. This is one basic example for level sensing. You also have frequency Doppler flow meters. The flow meters were elaboratively seen in industrial visit to RLT instrumentation. Ultrasonic transducer used as flow meter there was also seen. You have a transducer 1 and transducer 2, and transducer you have multiple transducers here. Transducer 1 and 2 and 2 and 1. You have ultrasonic pulse flowing through the water. If the intensity of the water or the volume of the water is quite a very large one, the pulse takes a larger time to get received on the other side. At the similar time, if the flow is lower, the time taken by the pulse to be received on the other side will be lesser. And this is given as the frequency in terms, it's elaborated in this equation in terms of frequency. One frequency for transmission and frequency is emitted frequency, and the transmitted frequency in the received frequency are given as 2 into Fe, that is twice that of the factor. The factor which involves the transit time, the angle of incidence, and also the velocity of the ultrasonic pulse. This principle is good. It obeys in liquids and also in the gaseous media. The two relations which are seen here, T12 and T21, talk about the intensities B and intensity C and the transit time T1 and T12 and T21. The ratio of T12 T21 is giving you the coefficient which will also govern the velocity of the total reflected wave and the received reflected wave and the transmitted wave. If the transducer 1 acts as an emitter and transducer 2 acts as a receiver in the figure given below, the time of the radiation to reach the receiver would be T12, which is a function of B, the sine alpha, that is sinusoidal of the alpha, the angle of incidence, and C, the velocity of the wave, and V, the velocity of the ultrasonic wave. And the T12, the difference of the timings T12 and T21 will measure the transit time for the liquid to transit time, and wherein the transit time is again further dependent upon the liquid's viscosity. So it can be also used as a the ultrasonic Doppler flow meter can be not only used for measuring the flow of the water, it could be also measured to detect the viscosity of the liquid. So these are the two examples which sensing examples of ultrasonic transducer. Further examples would be explained in the next lecture. Thank you.